So I hope I've gotten you interested in operations, at least as it is an interface with other critical parts of the business. We've talked about the Starbucks coffee phenomena and kind of how branding is essential, and it's supported by how operations works. And we've also talked in detail about the Rogue Fitness example, which is an example of a business I think any of us could do, and I think most of us would be quite proud of our business success if we had a company that we could create of that size. So what I'd like to do before starting to branch into some of the mathematical concepts we're going to be talking about is talk to you a little bit about that paper that I asked you to read called Deep Change. Now, Deep Change was written by a man named Mike Hammer. And if you were a bit older, if you were going to MBA school in the late 90s all the way through the mid 2000s, Mike Hammer would be a household name. Everybody would know him because he, along with David Champy, wrote one of the most successful business books in the history of business books called Re-Engineering the Corporation. And in the late first decade of this century, so I believe it was 2009, 2010, 2011 time frame, Mike Hammer wrote this paper, Deep Change, because he wanted to say one thing, and the same thing that I would like to talk to you about, which is they weren't wrong. Yes, there was a dot-com boom followed by a dot-com bust, but their essential message in Re-Engineering the Corporation holds as true today as it did then. And that's the intent of his paper, Deep Change. And I'd like to talk to you a little bit about it. It says, we have technologies. When we have technologies, such as the information management age, we have the web, we have all sorts of B2B applications and B2C applications. That is business to business and business to customer applications. We have the ability to write applications for smartphones and so forth. None of that changes this essential fact. You don't want to just automate what you already have. That's not enough. That won't get you far enough ahead in this world. What you instead want to do is ask yourself, how does this new technology allow me to do things differently than I've done before? And the way I'd like to show you that is by using something called data envelope analysis. It's a very interesting technique that was actually developed by a very famous man, Bill Cooper, who was a professor here at the University of Texas for many years, and before that was at Harvard. He had a profound impact on a lot of famous people, and he was one of the most famous academics in the area of kind of operations management and operations research. So let me go to the board and tell you a little bit about what Deep Change is talking about and try to use this data envelope analysis to give you a better understanding of the idea. Perhaps the best way to conceptualize this is to think about trade-offs. And I'm going to use an operations example. We're going to learn throughout this course that there is a fundamental trade-off between designing a business or a process that is very responsive versus designing a business or process that is very cost-effective. And it turns out you can't have both all the time. And if somebody says, I want you to design the perfect process that is the most responsive possible, as well as being the most cost-efficient possible, I'm going to tell you that's simply not possible. I'm going to say, I wish Santa Claus were true, but in the same way Santa Claus doesn't exist, that perfect process doesn't exist. There is a trade-off, and you're trying to find the balance. So let's think of trade-off, as I said, between responsiveness and cost-effectiveness. Now, the classic way of doing trade-offs and trying to find out the best way to design your business or your process is a weighted average. You give a score or a weight to how responsiveness affects your business. You give a score or a weight against how cost-effectiveness affects your business. You then look at your different choices, giving each of them a score in responsiveness, a score in cost-effectiveness. You calculate the weighted average, and you pick the choice that has the highest weighted average. This is absolutely traditional. Those of you who are engineers are quite familiar with what I'm talking about. There's a problem with that, and I think I can illustrate it with a little simple question back at you. Have you ever tried to make a decision where you went through and you came up with different factors, responsiveness and cost effectiveness? You looked at your different choices, you gave them a score, and you didn't like the answer. You plugged them all in and it says, choose option C, but you didn't like option C. So what you did is you either went back and changed the percentage you gave to responsiveness or cost effectiveness, or you went back and changed the scores until you got the answer you wanted. If you've ever experienced that, and I think most people have experienced that, you find the limitations of trying to do trade-offs in this kind of one-dimensional normalized manner. So Bill Cooper came up with a brilliant idea, and like most brilliant ideas, it's very simple when you think about it. Why try to put them into a single scalar number? Why not simply create a graph? And on this axis, let's call this the responsiveness axis. And on this axis, let's call this the cost effectiveness axis. Bigger numbers on responsive means more responsive, better. So this is better, this is worse. Bigger cost effectiveness is better, and this is worse. And then think of all your choices. Or, if you will, think of all your competitors in the field. And simply plot your choices or competitors against their responsiveness, cost effectiveness score. So perhaps one choice has high responsiveness with relatively low cost effectiveness. So see, on this axis, relatively low on cost effectiveness, relatively high on responsiveness. Another choice might be relatively high cost effectiveness, relatively high responsiveness, and so forth. And plot all of your choices or all of your competitors wherever they might occur. And once you have all of these choices, your job is to draw what's called the data envelope around it. This is the minimum envelope that contains all the points. When you do this, it might look something like this in this example. We call this the efficient frontier. The data envelope that constrains all of your choices defines what the efficient frontier is. Now, how is this any different from what we were talking about? We're trying to make trade-offs. And the interesting thing is, different markets value different trade-offs. So let's try this. How do I know whether I'm doing a good job with my current design, my current business, or my current choice? The simple answer is, if you are not currently on the efficient frontier, you're not doing a good choice. So question one, am I on the efficient frontier or not? Let me give you an example. What do I mean by being on the efficient frontier? Let's compare this position to this position. This one being on the efficient frontier, this one not. Notice, they both give roughly the same level of cost effectiveness, but this one gives a much higher responsiveness than this one does for that same cost effectiveness. This point dominates this point. Conversely, if we look horizontally, let's compare this one to this one. Again, you can see both of them are giving essentially the same level of responsiveness, but this is more cost effective and therefore the better choice. If you go through this process, you can mathematically show that by definition, once you understand all the trade-offs that are going on, all of the choices that are going on, then you can create this efficient frontier. And choice number one, am I on the efficient frontier or not? But then an interesting secondary question comes into play. Okay, where do I want to be on this efficient frontier? Being here on the efficient frontier is a completely different business proposition than being here on the efficient frontier or being here on the efficient frontier. And let me try to illustrate it maybe with an example. It's a little dated now, I guess, because we don't really know what's going to happen with healthcare. But let's talk about emergency care. Your daughter or your son has fallen off the roof and broken his or her collarbone. You now have to take them and get that fixed. It's not life-threatening, but it is an emergency and it needs to be dealt with. Think about what it means if you are a business providing emergency care on this portion of the efficient frontier. What you're saying there is cost effectiveness is more valuable than responsiveness. So when the trade-off comes, we are willing to trade off lower responsiveness if it gives us more cost effectiveness. Think of a municipal emergency room hospital, perhaps even the indigent care emergency room hospital in any particular urban area. In that case, when they're setting up their business, they're setting up their processes, what they're trying to do is they are trying to pick the choice, design the process that values cost effectively using their resources more than it values responsiveness. Cheaper, but you may have to wait longer. On the other hand, imagine all of those minor emergency clinics that are popping up all around. Insurance may or may not cover them completely. They're certainly more expensive. What's their business proposition? Their business proposition is responsiveness is more valuable than cost effectiveness here. That is, they will set up their business in a way that says, you don't have to wait, but it's going to be more expensive because we have doctors, nurses, support staff that are on call and they're not as well utilized. This is a different market proposition than this is. And in between would be any trade-off there between. So the essential issue of the efficient frontier is you can't design the perfect business without understanding the relationship between operations and marketing. What do I mean by that? Operations cannot tell you where you ought to be on here. Operations can only ask the question, what do I need to do in order to get to the efficient frontier from wherever I am now? On the other hand, marketing can tell you, here's where we want to be. But marketing doesn't know how to get there. That's an operations question. So this becomes a twofold question of, from a market perspective, in any given business with any set of trade-offs, where do I want to be on this frontier? And from an operations perspective, what do I have to do to get from where I am to that portion of the efficient frontier that marketing is telling me to go? And that's really important when you're reading or understanding Deep Change, because Deep Change says that entire discussion you just had is a B score rather than an A score when you're trying to create a business. Because it says our job is to emulate current best practices. And if we can use technology to emulate current best practices, or we can mimic other companies to mimic current best practices, that'll get us from where we are to the current efficient frontier. But Deep Change, like its predecessor, Reengineering the Corporation, says, but why limit yourself to the efficient frontier? Sometimes new technology, instead of simply automating what already exists so that you can get to the frontier, actually says there is a way to jump over the frontier and be outside of this efficient frontier, or if you will, to create a new efficient frontier. And Deep Change is simply the recognition that part of our job as business managers is not just to emulate what already exists and get to the current efficient frontier, but instead to also ask, what technology is available? What way of doing things differently will allow me to actually leapfrog the current frontier and create a new one? So as you read that paper and you're ready to talk about it in class with me in our face-to-face session, I want you to think about not just emulating best practices, but jumping over the frontier and trying to think about what my camera's saying.